Hi everyone. In the given problem statement of game of life, which is a medium level of problem, we are going to given a board of m cross n grid of cell, where each cell has an initial state, where life is represented by 1 and a date represented by 0. Each cell is interacting with its 8 neighbor if possible. Those are present horizontal, vertical, diagonal using the following 4 rule. Any live cell with fewer than 2 live neighbor dies because of underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any live cell with more than 3 live neighbor dies because of overpopulation, and if any dead cell is there with exactly 3 neighbors become a live cell by reproduction. So the next state of board is determined by applying the above rule. This is a very important statement. So you do not have to make changes on our current cell based on all the neighbors it has. We'll have to take in a dictionary format, take all the neighbors for all the rows and all the columns, or for all the elements, and then the replacement needs to be done. After replacement, we are not going to count it. Before replacement, we are going to count all the neighbors. So we need to have some mechanism to store this value. Let us take an example of the 0 comma 1 index, which is current value is 0. So it would have the neighbors are, this would be the neighbor, this one, this one, and this one. Other neighbors are not possible. So 1, 0, and 0 are the neighbor. So here, right, number of life count is going to be 1, and date count is going to be 2. Similarly, let us take an example of this index, which is 1 comma 1, and the current value is 1. So out here, its neighbors are 0, 1, 0, 0, 1, 1, 1, and another 1. So it has all the 8 neighbors that is present. So here, right, the live value would be 5, and date value is the value of it is 0, not 1, sorry. So date value would be 3. So if its value was 1, right, because it has a live population of 5, right? So here, because our condition, right, because the total number of live cell is more than 3, right? So this cell is automatically going to die. Now let us take an example of a cell which where a replacement might happen. So let us take the example of index 2 1, or let us take the index of 2 0. Okay, so currently the value of it is 1. So what are the neighbors of it? So neighbors of it are 0, 0, 1, 0, 0. Okay, so number of live value, right, is just 1, and dead value is 4, because the live value is just 1, right? So because of underpopulation, right, this cell is going to become 0. A transition is going to take place to 0. So in this way, right, so here the main problem is that how we are going to iterate through the matrix, and how we are going to store all the neighbors of it before we do the replacement. So there would come the main problem out of the problem in the given problem statement. So traversing the matrix is the crux of the problem. Now let us jump to the Python solution. So here, right, we have to modify the given matrices without changing anything, or we have to do an in place replacement. So for that, let us first have an h, which is going to be the length of the board, or the length, or the size, or the value of m cross n. So the total height of the matrix. So board, and then we are going to have another value w, which stands for the width. So it would be length of board of its first row. What is its row? Then we are going to have a value called dictx, which is going to be an empty dictionary for now. And then we are going to traverse the matrix. So for I in range 0 to length of board, for j in range 0 to length of board of the first value to get the width. Now let me have an array neighbors, which is going to be a list, empty list for now. Now our condition to find the neighbors of it. So for that, right, in case there could be a situation, right, it is the first row, right? In that case, you have to add some bounding condition. So if I minus 1 is greater than equal to 0 and j minus 1 is greater than equal to 0, in that case append board of I minus 1 and j minus 1. Let me try to copy it up for future references. Now if I minus 1 is greater than equal to 0, in that case neighbors board I minus 1 and the value would be just j. Similarly, if j minus 1 is greater than equal to 0 and j plus 1 is less than the w, so here we are checking for the bounding condition. So in that case our value would be, it would be I minus 1. So I minus 1 and the other would be j plus 1. Now for another condition, so if j minus 1 is greater than equal to 0, so all the 8 type of neighbors that we can have, right, we are checking for all of them. Now if j plus 1 is less than w, in that case the value would change from I and it would be j plus 1. So 3 more values are left. So if I plus 1 is smaller than h and j minus 1 is greater than equal to 0, so for that case it would be I plus 1 and j minus 1. Now if I plus 1 is less than h, in that case the value would be I plus 1 and just j out here. And I think the 8th condition, if I plus 1 less than h and j plus 1 is less than w, in that case the value would be, both of them would become plus. So in this way, right, we can find all the neighbors. Now the value of live would be neighbors dot count number of 1 and date would be neighbors dot count 0, and then we are going to add it to our dictionary. So dictex of I comma j is nothing but live and dead. Now once we get this value, right, we are again going to loop. So here, right, we have added all the neighbors of a particular element, right, into a dictionary. Now once we have looped through, right, and we have find out the total number of live and dead count, now we are going to do the replacement. So for I in range 0 to length of board, and for j in range 0 to length of board of 0. Now we are going to get the live and dead count is nothing but dictex of I and j. Now we're going to check for the condition. So if live is less than 2, in that case the value of board of I and j would become 0. If live is greater than 3, in that case value of board of I and j would become 0 because the cell would die because of overpopulation. And if live equal to 3, in that case it will reproduce and it will create one more value, so it will be 1. Board of I and j, it would be 1. Now let me run it through. So I hope there is no spelling errors. Line number 30. I made a big mistake. Let me see if I'm able to run it now. Okay, now the public test case is passed. Let me submit the code and let's see the output. So let me click on submit. As you could see, it is beating 100% of the submission. So our code is very efficient. So if I look into it, right, the time complexity would be big O of n square because you're traversing the entire matrix only one time. So that would be, oh no, it would be big O of n because we're just traversing to that entire matrix one. So total length of the matrix, right, it would be the means total number of elements in the matrix. It would be in that range. There would be few calculation to handle the edge cases so that the neighbor is not present, right? So you are not going to add that to that list, so you have to take care of it. And once that is done, right, it's pretty straightforward to do that. So now jumping on to the next question.